All right, so for example 4, we're going to now graph the tangent function. Now, for example 3, we did the cosecant function, and cosecant and secant pretty much work the same way. As long as you know that secant goes with the cosine graph, pretty much it's going to work the same way. Work pretty much the exact same way. Now, this one is tangent, and tangent is going to work the very same way as cotangent. So as long as you know how to do tangent, you can do cotangent, and vice versa. Now, with this part, we're going to deal with the pieces that are given to us. So it says graph y equals 6 tangent pi over 30 t. Sorry, my fault. So we're going to take a look at that, and we're going to go ahead and do the values and all that great stuff. So here, what we're going to do, and let me turn this on. So we're going to, first off, again, deal with our amplitude and all that good stuff. So just like before, this is the same thing. K theta minus C plus H. Now with this again, amplitude is 6, but when it comes to this part, really, the 6 will only come into play if we have to substitute a value for t and then work out the problem. But for right now, because it's tangent, the amplitude won't really do anything to the graph per se. So when we do all of this part, the really only part that we have to focus on, well, first off, let's go and still do that part. Our amp is still 6. It's not going to, again, not going to do much to the graph. But then when it comes to our k, we have pi over 30. And we're like, okay, so pi over 30 is k, so we can just do the regular period and be good with it. But the thing about this part that's going to be very important to remember, for tangent, and let me write this out, for tangent, and cotangent functions, the period formula is something different. It's actually pi over k. Now remember, for sine and cosine, tangent and secant and cosecant, sine, cosine, secant and cosecant, the period was 2 pi over k. For tangent and cotangent, it is actually just pi over k. Now for that, people forget that, and then they still divide everything, do 2 pi over k, and then work things out, and they get things wrong, and they can't remember why. They don't understand why. So here, just as a reminder, pi over k is going to be the period for tangent and cotangent. So when we do this part here for the period, we need to make sure we do that correctly. So here, if we do our period for tangent, and again, this works the same thing for cotangent, we'll do pi over k. And we know that k, in this case, is pi over 30. Okay, so we know, again, when we divide by a fraction, we do keep, change, flip. Let me do a different color here. So keep, change, and we flip it. Okay, so here, that means the pi's will cancel out, and we're left with just 30 for our period. And you're probably like, wait, we never talked about just 30, just a number. Oh, how do we do this? Mr. Hall is so confusing. This is pre-calculus. Why is it always so confusing? Oh my gosh, I quit. Don't do that. So everything else is going to be the same when it comes like to our new tick marks and all that good stuff. It's going to match up with that 30 so that when we put everything out there, it's going to be easy. Easy peasy lemon squeezy. So again, we're going to talk about our new tick marks. And again, we already know the old ones. We're going to divide them by the k. We already know that part because we just talked about that a few minutes ago when it came to the cosecant graph. And again, I'm going to do this vertically so that we can visually see it a little bit easier. And again, we're going to do keep, change, flip. So everything's going to be everything's going to pretty much be about the same as we had before. Well, not the same, but same idea, same concept. Again, so we divide everything by k, all over again. So again, we know here this is 0. We do keep, change, flip. Let me go ahead and do that for all of them. Just keep, change, flip part. And hopefully you will see that every single one of these pretty much are multiplied by the same thing. Oops, there we go, sorry. And each time this happens, because we said our period is 30, so that means each one of these most likely are going to cancel out the pi and just have a number. So we're going to cross reduce and cancel out what we can. So we're going to cancel out our pi's here. So this understood 1, pi goes into pi one time, pi goes into pi one time. And then here, 2 and 30, 2 goes into 2 one time, 2 goes into 30, how many times? 15. So our next tick mark is 15. Now I'm doing it in color purposely, in a blue color. Well, just to make it stand out. All right, so then here are the pi's canceled out. So again, that's 1, that's 1. So we're left with just a 30. Next part here, we cancel out that and cancel that pi out. And then here we get this and this. So that's 1, that's 15. And then that's 45. 45. All right. And then over here on this side, we get that to cancel with that one. And that gives us 60. All right. So with our new tick marks, we have the pi 0, 15, 30, 45, 90. Now with this one, because we're dealing with our tangent graph, and I'm going to do this all in one video, hopefully it won't take too long. But with our tangent graph, remember, it looks a little bit different because our tangent, the tangent graph goes through 0, 0. So with that, I'm going to start over here and then move over because we need to make sure we get things to look actually kind of accurate, kind of say, as you can say. All right, so I'm going to do on both sides here. So let me see, let me get here. So we're going by 15s, which hopefully you noticed that. So 15, 30, 45, sorry, and 60. And then here's negative 15 and negative 30, just to do that part. All right, now with this, we know that our tangent graph goes through 0, 0. And normally it's pi over 2 that actually has the asymptote. Well, the pi over 2 part now is 15. So that means where pi over 2 normally is, we're going to do an asymptote right there. Now with this one, because there is no phase shift, we're not going to shift anything around or anything. So it's going to stay like that. So normally it's pi over 2 is the asymptote. And then we have it go through the pi and then goes through 2 pi. So we're going to have an asymptote right here again, because normally at pi over 2 and 3 pi over 2, there's normally an asymptote. And if you go back again, looking at these, this is 0, pi over 2 normally is where the asymptote is. There's 3 pi over 2 is normally where the next asymptote is. And then 2 pi is where it goes through 0 again. So all we did was take those numbers at pi over 2, 15. So there's an asymptote at 15. There's an asymptote at 45. That's 3 pi over 2. And then I'm just going to do one on this side too, just to do it. You don't have to do the left side of the graph. So I'm just going to do it anyway, just to do it. And then we're going to draw the graph out. Bam, bam. And really at this point, because the amplitude is 6, let's say these are 6 right here. They're -6 down here, +6 here. Normally somewhere like around in here, that's where the actual point will be for that. So let me redo this. Let me redo it. Let's erase all this part. And just again, just to be for accuracy's sake, we'll say this is 6, this is -6 down here. You have this part in the middle, this part in the middle. And again, this is very vital because if you don't know your graph and you need to graph things out accurately, you won't be able to do it. So you must know these. Ooh, whew, Jesus, that's bad. You must know these graphs. Know them. Not know about them, know them. And then here. And again, hopefully you've hopefully you've already have all of the properties for the tangent and cotangent graphs and the secant and cosecant graphs like I had you do in the last videos or the videos before. So it's important that you know these graphs. Very important. Which means you have to take some time for that. Now here you can continue on if you want to do it on these two, but I'm not going to. We're just going to keep it like that. And that's good enough right there for us to see what's happening. All right, there we go.